All right, welcome to Unit 4. We're going to start with notes number 1, and it's about linear transformations. So, all of Unit 4 is all about linear transformation, or just linear functions. So, we've dealt with linear, quadratic, and exponential. Now, we're going to take those linear functions and really just look at all the individual pieces of them. We're going to look at everything that has to do with linear functions. We're going to look at word problems with linear functions, everything linear. That means that everything we graph in this unit better be a nice straight line. Okay, linear, everything must be a nice straight line. Okay, so since we're diving into everything linear, we're going to start with the parent function. So it says graph the parent function and describe the following characteristics. Also, if you do not have a calculator right next to you, you need to start by picking up a calculator. Okay, so it says graph the parent function and describe the characteristics. So for our parent function, we know it's going to be y is equal to x. And our input and output table, which you should have memorized, is -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. I say you should have that memorized because you took your test yesterday, so hopefully you did. All right, so we're going to plot all of our points, -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. We're going to connect all of our points. And so there's the graph of our parent function. So like we said, this is linear. We know the domain of all linear functions is all real numbers. The range is all real numbers. Our x and our y intercepts also go through 0, 0. They go through the origin. Now, these will never change for our linear functions, but these two will. Okay, they won't always be 0, 0. Alrighty, so we're going to be doing some sketches and just talk about what is happening to our graph compared to the parent function. So we're going to be talking about transformations today. So we're going to talk about how does the parent function change. So we know that our parent function is y is equal to x. So if we look at our first one, the first graph we're going to look at is y is equal to x plus 4. Okay, so how does this go from this to this? We are adding 4. Okay, so this plus 4, I want everybody to box in the plus 4. Okay, that is the transformation that we're going to look at. What happens when we add 4? So everybody pick up the calculator, go to your y equals, hit pause on the video, go to y equals, and type this function in, and then give me a sketch. All right, so I hope you went in and sketched or typed this in the calculator and sketched it. If you did, your graph should have looked something like this. Something very close to that. Okay, so that's what it should look like. Remember, our parent function looks like this. This is what our parent function looks like. I want you to draw both of those in so then we can look at these. So when we're looking at this, our parent function starts here, and then we jumped up to our new function here. So how did we go from here to here? Well, you should be thinking, well, it moved up. Okay, it went from here and it moved up to right there. Nothing else really changed about our function. It just was shifted up. Okay, so what happened when compared to the parent function? Our new function shifted up. How much did it shift up? You should be able to count the little spots. So 1, 2, 3, and 4. Okay, so it shifted up 4 units. Okay, so all we're saying is, hey, I put these into the calculator, it moved up 4. And which makes sense because of this plus 4 right here. All right, so looking at the next one, we have y is equal to x minus 2. I want you to go ahead and put that into the calculator and give me a sketch. All right, so hopefully you put that into the calculator and gave me a sketch. Remember, our parent function is this one. So our new function probably looked like this. Not probably, it did look like this. Okay, so we started with the parent function and now we moved to the new function. So we want to know what happened. Well, the difference here, we had y equals x and now we have y equals x minus 2. So the difference here is this minus 2. So what happens when we subtract 2 from x? Well, when we subtract 2 from x, we shifted down. Okay, so we shifted down, and if you count your squares, it's down 2, which makes sense since we're subtracting 2, okay, from our x. So when we subtract from x, we shift down. When we add to x, we shift up. Okay, so that's how my graph is changing. It's going up and down. It's just moving up and down. Okay, and that is what happens when we add or subtract from x. So what do we actually call this? We call this a vertical translation. So these shifts are called vertical translations. When a constant is added to the parent function, it shifts the entire function up or down. So when a positive number is added, it shifts the function. What we said, when we added 4, it shifted up 4. So it shifts the function up. When a negative number is added, it shifts the function. Well, if we looked at this, we went down here. So it shifts the function down. All right. So anytime we see a plus or a minus, we know, hey, we're either translating up or we're translating down. Okay, so we can call these shifts or translations. I will always probably use translations if I'm going to be honest. But if you write shifted up or down, I'm not going to get too mad about it. All right, looking at number 3. So it says using your graphing calculator, or you can use Desmos. We'll talk about Desmos when I get back. Graph the following and sketch. So we have y is equal to negative x. So first I'm going to sketch our parent function, which we know is just this. Short, sweet, and to the point. That's our parent function. Parent function is y equals x. So what's different about this new function? Our new function, our x is negative. We have a negative in front of our x. So I want everybody to take a second, graph this into your calculator. So go to your y equals, type y equals negative x, and look at your screen and give it a sketch. All right, so I hope you took the time to do that. If I draw my new sketch, your graph should have looked like this. So how did I get from my old graph to my new graph? I've heard a lot of people call this a few different things. Some people say it flipped. Okay, so I've heard some say it's upside down. There are a lot of different ways to describe what's happening here. Okay, so anytime we were going up, but now our function is going down, that's called a reflection over the x-axis. So anytime our x is negative, there's a negative in front of our x, we know that it's been reflected over the x-axis. So this transformation is a reflection over the x-axis. Makes sense, given the title of the box. This changes the parent function from increasing to decreasing. Alrighty. Okay, so recap on the first page. Anytime we add or subtract, that moves it up or down. Anytime we make the x negative, that flips it. It's reflected over the x-axis. This you have to say reflected over the x-axis. You cannot say flipped. Okay, this is the word I need to see. Alrighty, flipping over to the back page. Moving right along. So now we're looking at these new ones. So just a reminder, our parent function is y equals x. So if we look at these two, notice that now I have whole numbers in front of the x. I have a 2 and I have a 5. Okay, so we're going to start with y equals 2x. We're going to start by giving a sketch of the parent function. I want everybody to grab their handy dandy calculator and graph y equals 2x in the calculator and give me a sketch. All right, I hope you took the time to graph that and sketch it. Okay, if you did, our new graph looks like this. Oh, probably not like that. Just a second. Probably looks something like this. So I want to know, how did we get from the parent function to this new graph? Okay, well, what does it look like? First, the language that I want you to use, okay, is it's less steep. Or not less steep, sorry, it's steeper. Okay, think of a hill. This hill is pretty steep. This hill is even steeper. Okay, so it's steeper. So we are going to call this, it's been stretched. Okay, think of if I have this and I stretch it up and down, okay, it's going to make it taller, it's going to make it narrower, it's going to make it steeper. It's been stretched. Let's do the same one over here. Same thing to this one. Now we have y equals 5x. So if we were to put this into the calculator, this is our parent function. If I put my new function in the calculator, it's going to look like this. It's going to be super steep. So how did I go from this one to this one? It's even steeper. Okay, and so we're going to say again, it's been stretched. Okay, so anytime we have a whole number in front of the x, we're multiplying the x by a whole number. Okay, this is what we call a vertical stretch. Okay, so these transformations are called vertical stretches. When a coefficient with an absolute value greater than 1 is multiplied with the parent function, it stretches the function vertically. This makes the parent function steeper. Okay, so anytime you see a whole number, that's going to make it steeper. Okay. All right, last section, guys. We're almost done. We have y equals 2/3 x and then y equals 1/5 x. Okay, so go ahead and start with our parent function. Guys, to put this into the calculator, you have to use parentheses around the 2/3. Remember, you type that in as 2 divided by 3. Okay, so go ahead and hit pause on the video, or the video will hit pause for you. Okay, and go ahead and type that into your calculator now. All right, I hope you took the time to type this into your calculator. Okay, if you did, you would have gotten a graph that looks like this one, or very similar to that. So how did we go from the parent function to this function? Well, now it is less steep. Okay, it is less steep. And we're going to call this, you guessed it, probably from the box, we're going to call this a vertical compression. Same thing with this one. Parent function. Our new function has a fraction of 1/5. And it's, when you put it in the calculator, it probably looks like this. Okay, it's even less steep. Okay, so we're also going to call this less steep. Okay, and then we're also going to call this a vertical compression. So anytime there's a fraction up front, that means it's been vertically compressed. So if we look in the box, it says these transformations are called vertical compressions, obviously. When a coefficient with an absolute value less than 1, so a fraction, is multiplied with the parent function, it compresses the function vertically. This makes the parent function less steep. Okay, so looking at an example that you're going to see in your notes, I want everybody to write this at the bottom. We have y equals, let's say we had negative 2x plus 4. I would ask for you to write all the transformations. This is where you need to go through our equation and talk about all the things that are different about it compared to the parent function, which is y equals x. So I want to know, how did we get from there to this new function? The first thing we notice that's different is the negative. If we look at our notes, flip it over to the back or the front page, anytime there's a negative up front, that means it's been reflected over the x-axis. So we see that there is a negative up front. If it's going to let me get back to the other page, just one second. So if it's a negative, we said, if I scroll back down, The negative means it's been reflected over the x-axis. The next thing we notice is there's a 2. We said up here, anytime there's a 2 or a whole number up front, it's been stretched. Okay, we said the 2 makes it stretched. Okay, so that means we're going to say it's been vertically stretched by 2. By 2. And then last but not least, the thing that we notice is now we have this 4 right here. Okay, so the last thing we have to take care of is a 4. Okay, and if we look back at that front page, anytime we are adding or subtracting, okay, that shifts it up and down. Well, if it's 4, it's a positive 4, so that means it's been shifted up. Or as I like to say, it's been translated up 4 units. Maybe. There you go. Translated up 4 units. So this is talking about how is this different than the parent function. The parent function's here. This new function was reflected, then it was shifted vertically stretched, and then it was translated up. Okay, so those are all the things that are different about it. All right. Okay, so on your homework, you'll see little prompts that ask, was it reflected over the x-axis? Was it stretched or compressed? Was it shifted up or down? Okay, so you have to make sure you're answering all 3 of those things whenever we're talking about transformations. All right, you can move on to your assignment now.